So let's quickly return to a lesson that we went over on, I think it was Tuesday morning or Monday afternoon. We'll talk about negative exponents. So we remember how to work our quotient rule, and that it would let us handle a question like so: 4 to the power of 6 over 4 to the power of 4. Simplifying that, we would keep the same base. The base is 4. The exponent of 6 minus 4 because it's a quotient, which leaves us with 4 squared. Now we knew how to do that because of the quotient rule. Quotient rule states a to the power of x over a to the power of y. If we have a quotient with the same base on the numerator as our denominator, then our solution would be to subtract our exponents. We've been working with this for a few days, so we should all be pretty comfortable with our quotient rule. Now, how about something that looks more like this: 3 to the power of 4 over 3 to the power of 6. So we'll see what happens here. Well, we know from previous grades, if we expand this, if we expand our numerator, then 3 to the power of 4 can be written as 3 times 3 times 3 times 3. And we know that we can expand our denominator as well, which would look like 3 times 3 times 3 times 3 times 3 times 3. And we know we can cancel that out because 3 divided by 3 equals 1, 3 divided by 3 equals 1, 3 divided by 3 equals 1, and we can do that one more time, leaving us with 1 divided by 3 times 3, which is 1 divided by 3 squared. Well, our quotient rule, however, we can use, if we use our quotient rule to approach this problem that's written right here, then it should tell us we can subtract the exponents. So 3 to the power of 4 divided by 3 to the power of 6 should equal 3 to the power of 4 minus 6. Well, what is 4 minus 6? That's a negative number this time. It's negative 2. So our quotient rule, which we've applied here, and expanding, which we know from previous grades, tells us that we can come to the solution 1 over 3 squared. 3 But our quotient rule also tells us that 3 to the power of 4 divided by 3 to the power of 6 should bring us to 3 to the power of negative 2. So what we can learn here is that if we have a fraction with a negative, like so here, then we can rewrite that as a positive exponent in our denominator. So it would look something like, so our rule would look something like this: a to the negative x would equal 1 over a to the power of x. Okay, so we can take this rule that we've just come across right here, and what we can do is rewrite it just a little bit differently. So instead of writing a to the power of negative x, what I'm going to write is a divided by 1. And I know that a divided by 1 is the same thing as a. All of this to the power of negative x. I'm going to leave the right side of my rule the same. What we can see here, rewrite our right-hand side here. Instead of 1 over a to the power of x, I could write 1 over a, all of that to the power of x. Because I know When I expand this out, I would end up with 1 to the power of x in my numerator, and 1 to the power of anything is just 1. And I would end up with a to the power of x in my denominator, just like this looks here. So from this, I can see that a divided by 1 to the power of negative x equals 1 divided by a to the power of x. Oops, negative x there. So we can use this rule. A couple times to see that what happens is our fraction just gets flipped. So we can write, even if we had the fraction a over b here, if it's a over b to the power of negative x, that would equal b over a all to the power of positive x. We can use this rule in conjunction with the others in order to manipulate the exponents as we wish.